Augmented reality is transforming how we interact with digital information, from remote assistance and industrial maintenance to healthcare, education, and architecture. AR allows digital content to blend seamlessly with the real world. Unlike handheld devices, smart glasses enable a hands free experience, allowing users to remain focused on their task while interacting naturally with virtual information. Despite rapid advances in AR, many systems still lack environmental understanding. Virtual objects are often placed without considering surrounding geometry, object relationships, available space, or occlusion. To explore these challenges, I developed an AI assisted AR prototype focused on virtual furniture placement using Epson BD300 smart glasses. Now, let's look at how the complete system works. The BT300 captures the real world scene, and Unity sends the captured image to a Python server through a Flask API. On the server, YOLO performs object segmentation while OpenCV processes the detected regions. The system then applies placement logic to find a suitable position for the virtual object. Finally, the placement data is sent back to Unity where the virtual object is displayed through the smart glasses. The real question is, why do we send the image to an external computer? Basically, the BT300 has limited computational resources, so running heavy AI processing directly on the glasses is difficult. To solve this, the processing is offloaded to an external computer. The glasses capture the scene, the laptop performs the AI processing, and the result is sent back to the glasses. This allows us to use more powerful AI models without putting the processing load on the wearable devices. Another important part of a project is occlusion, which helps virtual object blend more realistically with the real environment. First, the real world scene is captured and the table is detected. The system then generates a segmentation mask for the detected table. Next, the 3D chair is placed in the scene without occlusion. The chair incorrectly appears in front of the table. Finally, the occlusion mask is applied, allowing a real table to appear in front of the virtual chair and creating a more realistic augmented reality effect. Here is a demonstration of our prototype. First, the real world scene is captured and sent for processing. The prototype demonstrates the placement using a 3D chair model, which is correctly occluded behind the real table. The user is moving, rotating, and scaling the virtual object for adjustment. This brings us to the end of our project. Along the way, we learned how to work with augmented reality, AI, computer vision, Unity, and wearable devices, and most importantly, how to bring all these technologies together into a working system. What we have built is a prototype, but the skills we gained can take us much further towards smarter application, advanced wearable systems, and real world solutions.